Okay, so here is a little extra snippet in preparation for the parent function YARF tomorrow. So again, we've talked about these parent functions a lot, and so on the YARF you'll be given the name of the graph, like linear or maybe the function, and then you have to draw it. But you do want to draw it accurately, okay? So again, you're not going to be labeling points and stuff, but you know that the linear function goes through 0, 0. So if you're drawing it correctly, yours will go through 0, 0. It'll be a straight line, and it'll go through all these diagonals here. The quadratic, the parent function, the vertex is at 0, 0, so yours should be at 0, 0. It also, the graph has to extend through the whole graph. You cannot stop here or here. Now, let's talk about this a little bit. In class today, we called this the hyperbola function, and I said I think that's kind of old-fashioned. So I would like to call this the reciprocal function. And then this one here would be inverse squared or reciprocal squared. Okay, now these are the functions, the parent functions that have the asymptotes. So we have a vertical here and a horizontal here. Now you do not need to draw them on your paper, but when you're drawing this branch here, if your branch touches the axis or crosses it, that's not a correct drawing. Same thing down here, it cannot touch it or cross it. So if you want to make yourself a note somewhere, just so you're sure, we do have a vertical asymptote here and a horizontal here, which are the x and y axis. Same thing for this function. So again, we have the absolute value, the exponential, and then we added on the exponential with base e, the natural log function. So I think in fourth hour we said it didn't go through 0, 1, but it does. It goes through 0, 1 just like the exponential with base b. Okay, so actually, if you look here, you can Google these images, so you can see the green graph is the one with base e, and so the blue one would just be exponential, you know, base 2. So this would be 2 to the x, we have e to the x, and 10 to the x. So they all go through the point 0, 1, but depending on what the base is, depends on how rapidly the graph increases. Okay, so also remember that we have the natural log, or the logarithm graph right here, and so there is an asymptote, vertical asymptote on the y-axis for the parent function. So again, when you're drawing this branch down, it cannot touch or cross the y-axis, or else it's wrong, and it shows that you do not know that there's an asymptote here. And again, here's a key point here. It goes to the point 1, 0. Our step function, our greatest integer function, again, the closed holes, those points are valid x values, but the open holes are points of discontinuity. And then back to the square root. The square root does not have an asymptote. Remember that. It does not have one. It stops here. We do not have any negative x values because we cannot get a real number when you take the square root of a negative x value. So you will not see any of these points shifted over into the second or third quadrant unless there's just a shift of this function. So a child might be shifted over here, but the parent function is not. Like I said, your life will be much easier if you know these functions go through the origin here. Okay, this reciprocal function has the asymptotes, but it also goes through the point 1, 1, negative 1, negative 1. Right here, the inverse goes through the point 1, 1, and negative 1, 1. Origin, again, this point goes through both of the, any of the exponentials go through the point 0, 1. And then the log, again, just to remind you, goes through the point 1, 0. So, happy studying. Know these well so you can do them in the time that's given to you. Good night.